Hey students, in this video I'm going to go over the questions that clarify the pattern between the 45, 45, 90 and 30, 60, 90. But I'm going to do separate videos. So this video is on 45, 45, 90 and the next one will be on 30, 60, 90. Okay, so all right triangles have 90 degrees, but there's a special pattern in the sides of a triangle that's 45 degrees, and 90 degrees. Whenever you recognize that you have this type of triangle, you want to annotate a pattern that the sides have. The legs that you have in this triangle are going to be congruent because the angles 45, 45 are your base angles and they're congruent. So it's an isosceles triangle, which means that whatever side you have, let's just say x will represent it. It's an unknown value. It's just a side. And they're both equal. So you're going to have whatever side is here, it's also here. The hypotenuse, though, you're going to have x squared root of 2. So always you're going to follow this pattern of the side that you have times square root of 2. So if you need to see a little annotation there of what these represent, this is a side, and then this is the side times square root of 2. Okay, so here are a couple of examples to go over and apply that. You recognize that you have a 90 degree, 45 degree, so the other side has to also be 45, which means that these two sides are congruent. And I'm gonna color coordinate just to kind of emphasize the strategy. These are congruent, they're both equal, so you kind of annotate that. And the pattern that it follows is that this represents x, this also represents x, and this represents x squared root of 2. Then you ask yourself, what information are you given? In this specific problem, you're given the number 8 representing a side. So if x is there and 8 is there, you can assume that x equals 8. Not this x specifically, but the x representing the side in the pattern. So if that is 8, this side is congruent to that, so this is also 8. And then this is x squared of 2, so we're going to say 8 squared of 2, because we're replacing this x with the number that we got. Now we can finalize our answers by saying this side is 8, this side is 8, and this side is 8 squared root of 2. So to answer correctly, x equals on this triangle the number 8, and then y equals on this triangle 8 square root of 2. Okay, let's try that again with a different triangle. You recognize the 45 degree right here, so that means this is also 45, 45, 45, 90. Then you recognize the legs, which are these two, and those are both congruent. And whatever they represent, they're both equal. So we put an x to represent that. Then you have this hypotenuse, which again follows the pattern of x squared root of 2. And then after you label the side lengths following the pattern, you ask yourself, what are you being given? So you're being given this 28, and it's on the side of the x, which means that these two are equal. We can assume with this information that x equals 25. But this x means this x right here, and then this x right there. So this side is 25, and then this side is 25 square root of 2. Now to answer what it's asking, x is right here, so that's 25 square root of 2. And then y is right here, so that's 25. Okay, let's try one more problem. We have 45, 45, 90. So we're gonna annotate that these are the legs. So this is x, this is x, and this right here is going to be the hypotenuse. So that's x squared root of 2. Now in this case, the answer that you're given, 19 right here, is going to represent this part. So you gotta annotate that they're equal. X square root of 2 equals 19. And then from there, your job is to identify what is x equal in this situation. Well, remember, x and square root of 2 are multiplying each other. So to solve for x, you want to undo this multiplication by dividing by square root of 2. And then that's going to cancel this part, and you're going to get x equals 19 square root of 2. 19 divided by square root of 2. However, we said we cannot have square root of 2 on the bottom. So we're going to multiply. We're going to apply what we did on the previous video, simplifying divisions. We're going to multiply times the square root of 2 on top and bottom. This becomes 19 square root of 2 on the top, and square root of 2 times square root of 2 just becomes 2. So this is the side that represents x. X equals 19 square root of 2 over 2. Now I know there's a lot of x's and y's, so just be careful understanding what you just found. You just found what this x right here represents. And if you found that x, then you found this x, and you found this x. So that means that if these two variables represent these two sides, then the answer is the same on both. You're going to write 19 square root of 2 for that one, divided by 2, and then 19 square root of 2 divided by 2 for the other one. They are the same size. In class, I showed how these answers make sense. So I'm just going to show you an example. If you have a triangle that does have those side lengths of 19 square root of 2 over 2, and then another side of 19 square root of 2 over 2, and then you have 19 right here, you could do Pythagorean theorem to check if this makes sense. So our legs on this triangle are here, and if I was to type on the calculator this leg squared, so I'm going to write 19 square root of 2 over 2 squared plus the other leg squared, I forgot to put a plus. So what this equals is 19 squared, because it's equal to c squared. So a squared plus b squared equals c squared, and then notice that the answers are the same. So this confirms the Pythagorean theorem is correct in proving that the calculations are correct. There are more problems to practice, and that's what we're doing in class. So hopefully these 3 problems help you.